Okay, today we're going to look at how to write a quadratic given two roots, and then also given some of the roots, finding all the irrational or complex roots of a polynomial. So there's the complex root theorem and the irrational root theorem. They're very similar. One deals with complex numbers, the other one deals with irrational numbers, and basically says if a polynomial p of x has a degree greater than or equal to 2 with real coefficients and has a complex number like a plus bi, then as a root, then the conjugate a minus bi also has to be a root. And that's the same thing with an irrational root. So if a plus cb is a root, then a minus cb has to be a root. So complex numbers are numbers with i's in them, and irrational numbers are numbers that have square roots that can't be simplified. So first of all, we're going to be given two roots, and we're going to be finding the sum and the product. So hopefully you remember sum means that you're going to add them. The product means you're going to multiply them. So on A, we have 4 plus 2i and 4 minus 2i. So we're going to add them. And when you add complex numbers, you add the real part with the real part. So 4 plus 4 is 8. And then 2i plus a negative 2i would be 0. So the sum would just be 8. The product, you're going to multiply them. So you get 4 times 4 is 16. If you do 4 times negative 2i, you get a negative 8i, and then 2i times 4 is positive 8i. Those are going to always cancel each other out, and then you'll just have to do 2i times a negative 2i, which is negative 4i squared. And if you remember, I squared equals negative 1, so you have 16 minus 4 times a negative 1, which would be 16 plus 4, which would be 20. So the product is 20. On this one, we're going to add. So again, real part with real part. Integer with integer, irrational with irrational. So 3 plus 3 is 6. Negative radical 2 plus a positive radical 2 is 0. So the sum is 6. Product, we're going to multiply. I'm going to be multiplying these. Again, these two times these two, and then when I do outside and inside, those are going to cancel each other out. And then, so I'll just do 3 times 3 is 9, minus radical 2 times a negative radical 2 times a positive radical 2 is radical 4. So you have 9 minus 2, which is 7. So the product is 7, and the sum is 6. Down here, if I add these, the sum would be radical 3 plus a negative radical 3 would be 0. The product, if I multiply them, I would get negative radical 9, which is just negative 3. Here, the sum, if I add those, again would be 0. And the product would be 25i squared. Again, I squared equals negative 1, so we get negative 25. So there's a formula that if you know two roots in a quadratic, the two solutions, the two x-intercepts, or another name for that is a root, that you can write the quadratic given those two roots if you know the sum and the product. And the equation will be x squared minus whatever the sum is times x plus whatever the product is. So on 2a, if I look at the sum is 8 and the product is 20, I can write the equation x squared minus 8x plus 20. And for b, if my sum was 0 and my product is negative 3, I have x squared plus 0x, which is not be a term, and then minus 3. For c, my sum is 6, my product is 7, so it's x squared minus 6x plus 7. And then finally, my sum here is 0, my product is negative 25, so it'd be x squared I'm sorry, this is minus 25, which would make this plus 25. X squared plus 25. Oops. So over here on the back, they're going to give us some roots, and we're going to have to find the other ones. And so if I know negative radical 3 is a root, I also know positive radical 3 is a root. So I need to come up with the polynomial that gives me these two roots. Once I find that, I'm going to do long division into this one to find the remaining polynomial, and then hopefully I can either factor that or do the quadratic formula to find the additional ones. So again, the sum of these two roots is 0. The product would be negative radical 9, which is just negative 3. So the polynomial would be x squared minus 3. So now I'm going to do long division, doesn't want to stay, with x squared minus 3, dividing that into x squared, x to the fourth minus 2x to the third plus 7x squared plus 6x minus 30. So x squared minus 3 so we have x to the fourth divided by x squared is x squared. Then I will multiply x squared by both of those, so I get x to the fourth minus 3x squared. So remember, we're going to put it underneath like terms. I'll subtract. This gets brought down. 7x squared minus a negative 3x squared is 10x squared. And then I'm going to bring down the 6x. Then I'm going to do negative 2x cubed divided by x squared, which is negative 2x. Negative 2x times x squared minus 3 is negative 2x cubed plus 6x squared. Is 6x. Whoa! So that goes there. Those are going to cancel. Bring down the 10x squared. That's going to be 0 and bring down the negative 30. 10x squared times x squared is 10. 10x squared minus 30. Subtract. No remainder, which that's good because I know those should go in evenly. So then I'm left with x squared minus 2x plus 10. And that isn't going to factor. So I'm going to use the quadratic formula. So opposite of b, plus or minus 4 minus 4 times 1 times 10 all over 2 times 1 is 2. And then I have 2 plus or minus 4 minus 40 is negative 36 all over 2. So 2 plus or minus, that's going to be 6i over 2. So x equals 1 plus or minus 3i. So all of my roots are negative radical 3, positive radical 3, 1 plus 3i, and 1 minus 3i. So on this next one, I know 2 minus I is a root. That also means 2 plus I is a root. So my sum is 4. My product is 2 times 2 is 4 minus I squared, would be 4, minus a negative 1, which would be 5. So x squared minus 4x plus 5 is my polynomial that I'm going to be dividing by. X to the 4th, 5x cubed. Right, x to the 4th divided by x squared multiplied by all three. Subtract. So this will be minus a negative would be plus, so that would be negative x cubed minus 8x squared, bring down the 43x. Negative x cubed divided by x squared is negative x, multiplied by all three.